Hey everybody, it's Mr. Harper Smith here. It's good having you back. Today we're talking about the difference between differentiation and anti-differentiation. Now, up till now we've talked a lot about differentiating, how to differentiate, how to get the derivative of a function. As an example, just a quick reminder, if you had, let's say, y equals 3x squared plus 2x minus 1, and we wanted to take the derivative, well, 2 times 3 is 6x, that'd be y prime. The 2 you minus 1, that gives you 1, x to the first power is just x, we don't have to put the square on there or anything. Plus, well, there's a 1, 1 times 2 is 2, but x to the 0 power is just 1. 2 times 1, well, that's just 2, so we're just going to leave it as 2. Here you have x to the 0 power, 0 times 1 is 1, so we don't have to write it down. This is the derivative. The derivative will always tell us what the slope, or if you're over in Europe, the gradient, I think it's with an A, gradient, it's with an E. I don't know, I'm not an English teacher. Okay, it tells you what the slope is at any point. So 6x plus 2 is the slope at any point along this curve here, okay? Well, that's great, but what if we went backwards, okay? Backwards, we're gonna talk about anti-differentiation. Just a small thought, if you're going backwards, well, y equals 3x squared plus 2x plus 8 is almost the same problem, right? It's almost the same thing. The only difference is the plus 8, where it crosses the y-axis. When you take the derivative, y prime is 6x plus 2. They have the exact same derivative. It's just where they start is different. That's the only difference between these two problems, okay? So when we look at a problem, let's say I'm telling you, you know what? Y prime equals 6x plus 2. And I say, all right, what was the original equation? Integrate or anti-differentiate. I want you to go backwards now. Well, we need to start thinking, all right, what would have the x's been? If you can remember how the x's work, then this works out really slick. So this x would have been an x squared plus something times x, then something on the end. So plus c is what we'll normally say. Something could have been a 0, could have been an 8, could have been a 42. We don't know. All right, well, 2 times what equals 6? Because remember, you would have brought that 2 down. You would have done 2 times something and got 6. What would that something need to have been? 2 times 3. 2 times 3 would have been 6. All right? Well, here it would have been 1 times something equals 2. 1 times what equals 2? 1 times 2. Okay? This would have been the original equation. Again, we don't know if it would have been a -1 for c, an 8, a 42, so we just leave it as c. Okay, there is some starting point. We don't know what that starting point is, but there was one. Let's try another problem. All right, here's another problem. We want to integrate 6x squared minus 2x plus 1. Quite often when you are asking somebody to take an equation such as this and find the original equation, where this is the derivative, you would say integrate. Sometimes you say anti-differentiate as well. They're both correct, okay? Well, in order to do this, we're gonna get our y equals, let's see here, what would the numbers be? This x would have been an x cubed, correct? Because you would have brought the 3 down, would have made an x squared. This would have been an x squared. Then this would have just had an x, then a plus c on the end. Well, now we need to go through and we need to figure out what would have been those numbers in front of each of the x's. Well, 3 times what equals 6? 2. Okay, so 3 times 2 would have made 6. Here, 2 times what equals -2? -1. 1 times something equals 1. What would it have been? 1. Okay, I'm not going to bother putting a 1 there on either of those because isn't just x the same as 1x? Let's be honest. Then finally, plus c. So this equation, no matter what c is, it could be 8, could be 20, could be -40, could be 3,572. If you take the derivative, its slope is 6x squared minus 2x plus 1. Let's try another problem. All right, here we go. Let's try this problem. So this problem here, we've got 6x to the negative third plus 4x minus 8. You haven't seen a lot of negative exponents, but it's still the same thing. If we had, let's say, 6x to the negative 8th power, and we took the derivative, well, remember, you multiply, negative 8 times 6 would be negative 48x, then you subtract 1. What's negative 8 minus 1? It's negative 9. That's how you would take the derivative if it's a negative exponent, just as a quick reminder. So here, we're going to do the same thing. Well, if we are, instead of subtracting 1, we're adding 1, what's negative 3 plus 1? It would be negative 2. Add 1 here, that'll give me x squared. We have an x, okay? Well, negative 2 times what is positive 6? Negative 2 times negative 3 is positive 6. 2 times what is positive 4? Be times 2. Have the negative 8 plus c. That would have been the original equation. Okay? If I take the derivative of this equation, I get that one. We're just going backwards, All right, let's integrate this problem. So we want to figure out what was the original equation. We've got y equals, this would be x to the negative 5th power, because remember, you add 1. When you take the derivative, you subtract 1. When you integrate, or when you take the antiderivative, you add 1 to the exponent. Maybe I should have written that at the beginning, but I didn't. Oh well. Okay, so you add 1. So negative 5. Add 1 to negative 2 gives me negative 1. Add 1 to 1 squared plus c. All right, negative 5 times what is positive 5? It would be negative. Just negative x would do it. Because negative times negative 5 would be positive 5. Negative 1 times what is positive 6? Negative 6. 2 times what is negative 4? Negative 2. That is the original equation for this problem. All right, I want you to try this next one on your own. All right, here we go. I want you to try this one. I want you to integrate 4x minus 12x to the negative third plus 12x to the negative fourth. Quick hint, remember to add 1 to your exponent. Pause the video. All right, you should have paused the video. We are now going to go over the answer. You should have the answer that you should have got by yourself. All right, so we add 1 to each of the exponents. That's the first thing I always do. I always go through, I add 1 to the exponents. Gives me x squared, gives me x to the negative 2, gives me x to the negative 3 plus c. We don't know what c is, could be anything. All right? Well, as I'm looking at this, 2 times what is 4? This is why I always do the exponents first, because I need to know what to multiply this blank by. If I don't know what this number is, so I can't multiply 2 unknowns to get a number. But if I know at least one of them, I can figure out what the unknown is. All right, so 2 times 2 is 4. Negative 2 times positive 6 is negative 12. Negative 3 times negative 4 is positive 12. Okay? This would have been the original equation. Okay? This slope defines this derivative here defines the slope for any equation that follows this form with any c value, any y-intercept value, okay? Hey guys, so back to the beginning. What is the difference between taking a derivative and integrating, or anti-differentiation? What is the difference? With the derivative, when you take a derivative, you get the slope, all right? If you want to know what the slope is at any point on a curve, you take the derivative, all right? But what happens when you go backwards? When you go backwards, it tells you the area under the curve. So for instance, let's say we have the equation negative x squared plus 4. That would look something like this, okay? Where it would cross at 2, 1, 2, 3, 4. It would look something like that. What if I wanted to know the area under this curve? Well, last time we were doing that trapezoidal rule, all that left approximation, right approximation. That's great and all. But if you want to know the exact value, you have to integrate. So if we tried integrating this problem here, okay, So we've got negative x squared plus 4. So if we integrated that, that would give me x cubed plus something x, well, that'd be 4x. The negative x cubed 3 times what equals negative 1? Negative 1/3. So this equation, if I figure out the difference between 4 and positive 2 and negative 2, it would tell me the area under this curve. You're not doing this today, this is what we'll do later, but just so you know why this is important. So what we would do is we would say integrate this from negative 2 to 2. Negative 2 to 2. At 2, you plug 2 in, that gives you negative 1/3 times 8 plus 4 times that is 8 minus the negative 2, plug negative 2 in, that would be positive 1/3 times 8 minus 8. Let's see here, 8 minus negative 8, that gives you 16. The negative 1/3 plus 8 minus that would give me a minus, let's see here, over 3, 16 thirds. Let's see, so this is going to be the same as 48. 48 over 3 minus 16 over 3. This leaves us with 32 over 3, which is 10 2/3. So the exact area under this curve is 10 2/3. You could have used the trapezoidal rule, could have tried to use the left and right approximations. They'd get you close, but this is the exact answer, okay? All right, give the assignment a try. You don't have to do this step for today's assignment. This is something that we'll get into a little bit later. Just wanted to show you why we bothered taking an antiderivative. All you're doing today is just basically that first step, going from the derivative equation to the new equation. Good luck.